Well, that's not wrong. I got my mom, and that counts.
So this records too as well.
Yeah.
We can get like a copy of
Yeah,
it.
yeah. So I'll send it to you.
Oh,
Just shoot me an
perfect.
email and remind me. 'Cause
Yeah,
I
yeah.
forget.
No
And
worries.
don't pull the Dave.
Mm.
Don't cuss on the hot
Oh
mic.
yeah, yeah, yeah.
Oh yeah.
It's hot now, so
It's hot now. Is it on?
yeah.
Nice.
Yeah, let me
So
just
are we
check and
streaming?
make sure that everything looks okay.
Dave, is that you? We're making fun of you.
Yep. So I think we're all good. I'll watch it before you start. Just make sure everything
No.
seems fine. Should be all set. Just make sure to hit that.
So if I do lights off completely,
You can do that too.
is
yeah.
that good as well,
Mhm.
or is that okay too much?
Yeah, just if you have anything to read up here, which it doesn't look like it. The other one keeps that on, but yeah, you should be fine.
Yeah, I don't need to read anything.
Okay.
Elaine realized she totally forgot to turn the lights off at all.
Oh.
It'll still be fine if you forget, but it just
Yeah.
it helps to look.
Oh no, I'll make it real dark in
Okay.
here. Don't worry.
Then yeah, here's this. I'll leave it back here.
I'm more of a moderately dark kind of guy.
Yeah. I was gonna have him hold on to the mic and then
Okay.
he'll pass it.
Is
around.
it stay on?
No.
No. You just talk during the presentation. Boo.
Like yeah. So this little green light will come on if it is on. You have to press it kind of hard too.
Oh, okay.
And then when do you start tomorrow?
Same time.
Okay. I don't know. It's scheduled from 8, but I'll probably show it at 8:30.
Oh yeah, no, that's fine.
Okay.
That's fine.
Sounds good. If you need anything, just let me know.
I
I'll be
think
in the
they
building.
just book everything from 8 on.
Yeah, it seems like it.
Mhm.
We usually have some extra time just in case.
Yeah.
Okay, cool.
All right.
Yep, let me know if you need anything else.
All right. Thank you.
You're welcome.
Now I just gotta memorize my presentation. I still have yet to do.
Man, that's something else right there. So that just goes straight to YouTube?
It's live streaming right now
Mhm.
to the friend and YouTube channel.
Oh, okay.
I was gonna look it up right now, actually.
That's awesome.
That'd
So
be
it's like a webinar type thing.
Exception. You can't do that.
Live stream on YouTube.
It's like if you go back in time and see yourself.
So where are we sitting at again before everybody starts?
I got my stuff right there. I need to go grab some beat real quick. Harass the competition. It's Lisa.
I can see myself. I can see my presentation.
That's awesome, buddy. I'm telling you, man. Perks of going to a school like this, buddy.
Mm-hmm.
Some cool stuff. You not ready to be done, buddy?
Yeah, but then like never really ends.
But believe me, man, when you get finished with this, it's like a weight that is lifted off of you like you cannot believe. You already got your manuscripts and stuff? Have you already got X back from people? From publishers?
Most of mine. For one. Only one. Yeah, Mike said it's gonna be pretty good.
That is awesome.
Yeah. I figure that's like what I need to do is like go finish one chapter, write it all the way up, and then
Yeah.
Because it's just like once you have everything at the end and you're like,
Dude, hey, I just tell you, that's awesome. Man. Get ready to. Already got that in the works, and now you're going to defend today. What else do you have to do except look at it? That's it. That's all you got left.
Not mess up.
No, dude. That's, you can't mess up. You can't mess up. Your work's already in the works to get published, so how are they going to tell you your stuff's wrong if you're going to you know what I mean?
Mm-hmm.
So just rest easy knowing that you're there.
We have that way. So I'll deal with 6 on the way.
How was that? Was that pretty good?
It's fun, but it was like, yeah, I was like, I should be
Too much.
working on my
Yeah.
presentation.
Yeah. Yeah.
down. Friday, Saturday, Sunday. Drove down.
Yeah.
My sister flew in from Orlando. Yeah, no, that's good.
Worked hard.
Yeah. It's something crazy. I was hoping to have not a lot.
I got some arrows from your game.
Yeah, he's told me. Yeah. It's like every day, 3 o'clock. I gotta go.
How's it going?
Hey.
Feeling all right?
Yeah.
Got your nerves getting you?
No, not anymore.
You got water to drink?
Eric. No, I didn't.
You want a cup of water for when you get up there to
It's
get
45 minutes later, and I'm yeah. I'll probably.
We'll get you some.
Have you ever seen my dress so short?
Oh, it's great. This is setting the standard.
Mhm.
I'm just disappointed in you here, frankly, that your lab mates, you didn't wear a suit to your own lab mates.
I know, right?
I almost sent an email out yesterday like, I want everybody Sunday best, all your lab mates' defenses. But I was gonna wear a jacket today, and I packed it this week. It's in the pond in the yard right now.
Look at that guy.
Yeah.
Who is it, man?
I just wanted to make sure I dressed better than Hunter did, so that was the hell of the goal.
Oh, well. Yeah, that was tough.
Three-piece will, yeah, three-pieces will do that.
Mhm.
Is that three-piece, three-button? Or two-button? Okay.
Two buttons.
Three-piece, three buttons.
It's a little much.
That's pretty good.
Well, you get all those chapters I sent you?
I did. I looked through.
That is good.
Yeah, thank you for those ads. Gonna be definitely helpful.
It was fun to finally actually do it.
Just had to read
Yeah,
it.
just go, oh yeah, I remember this.
When we first did it,
Oh, this is a couple years ago.
2 years ago, you mentioned something around those lines. Yeah.
Birds? Really?
The whole bird section. I was like, oh, birds, oh yeah.
We thought, we were wondering if you had, because we were gonna just not do it. If we knew you had forgotten.
Yeah, I did.
But I think it turned out pretty cool. I think the whole
I sent you that paper, really similar to Lindsay's.
Yeah, I've heard that one before. Like back when I first started. But
Yeah.
I think that's where I got the idea too.
Oh, cool.
This is
I
the
actually read
system
some
that-
more papers, it's nice.
Yeah, like I run a lot of Asia's papers starting out.
Oh yeah, yeah, she was active.
Mm-hmm.
Kids in all of all kinds.
Mm-hmm. We do this. No, but we can't do that.
Where are we doing that part?
One place.
You get the technology and stuff for Connor.
And we're gonna zoom them in here. And Alina's with me.
Which is really silly. To like travel to participate remotely seems odd.
Unless you just took it like as a vacation. I don't know, take this.
Sure.
Yeah, we gotta see if she's like genuinely upset. that we
She's
did
not.
that. Okay, she's just not doing it.
No, I'm sure she's not. Don't worry about that. She's not. She's
Well,
just
for a
curious.
second I was thinking like, oh.
Did you send it to her? Because that email, she was like, send it to me now.
I'll throw you under the bus with that. I asked you.
No, I said it was ready. You wanted it out the door. And that's true. I mean,
Yeah.
so like, don't. It's fine. Did you give him a cup of water?
Yeah, okay.
Oh, I thought you said, did you? He didn't even hear the conversation, but like, did you get it?
You want one?
Yeah, just a little.
Quick sip.
You
Okay.
need a top on that? I'm gonna be.
Speaking of arrows, just tell me,
Speaking of Arabs.
Arrows.
Arrows. Oh gosh. Oh, that was Sal or San?
Sour.
Sao Paulo. Sao Paulo. Your mom's gonna laugh. I just met you.
Did you heard the accent?
You got it out.
My sister was joking. I was just see it. Okay. You should just stay here. No, we're going. They will understand this.
You just put on a really thick accent.
I know that's what I thought. Start off with a really thick accent like my parents, and then.
Let me go out. When you use the methods again, you get back in the accident, come back out. I think that would be better.
It's working out.
Morning. Morning. How are you? Good, thanks. Inside your husband's truck.
No way.
Who knew that an arrow would go through the windshield of a truck?
Oh.
This is after me saying like 3 times, Tom, I just feel uncomfortable. Maybe you should move one of the cars. Like just one. Just a little.
Never.
And then he comes usually in the house. I'm like, what's going on? And he said, I don't know what happened. I have never.
I'm sorry for laughing because it's honestly,
I would at first I had this like fury.
Yeah.
That I was trying to like control. And then I was like, well, you're not getting any Christmas presents.
I got a little better.
Yeah, that's it.
Wow.
New windshield.
Ooh.
You know, the good news is, like,
Like
at
double
least,
one, double one.
he's got your friend. At least it was the windshield and not like a block. I feel like that would have been more expensive.
And it's got good
Did something.
It was really far away, so he said, you don't know what happened. Like, you didn't knock the arrow right, or I don't know. He was like,
This is really fun.
well, I don't know what happened. The arrow didn't go where I wanted it to. And Mars, I think,
Excuse me. No, Hunter's gonna be the one where. Yeah.
well, yes, the whole, everyone should just be wearing pink myself. I was like, no.
Then you just feel better.
And, sometimes I just have to do this. I was doing it and I had my sock and then I kind of snapped out of it.
Yeah. Thank you. I'll need it.
You look so nice.
Thank you. I just have to look better than mine. It's the goal plan. It's the entire plan. Make the white man look weak.
It'd be hard to beat my windshield. Good thing I already had another one.
We'll get it done.
I mean, of course.
Yeah. One more.
It's good. I worked on it, so promise you I get it. Well, it's all right.
I only need 2. I'm just gonna cut it off. That's the second chapter.
There's a third chapter, but I think we're good. Confidence. Cutting here. Really
Finale. Hopefully.
If I get my video put up there, you should have it. Let's go for it. Be the deck of lights.
Good morning, everyone. It's 9 o'clock. Time to get started. Okay, so today we're all gathered here to see Marcelo defend his thesis work. And I'm really excited to see this work. I'm really proud of Marcelo and all the stuff that he's done. He was the first student that I recruited here at Virginia Tech. He bore the brunt of my unrealistic expectations of an assistant professor, which was like 6-chapter thesis. That's what you should do. You need all these side projects. You need to mentor undergraduates. And he just did all those things. And now I'm sort of personally revamping my approach to this job. So Marcelo did succeed even in spite of those unrealistic expectations. So Marcelo was born in Brazil and came to Texas as a young child, 2 years old, lived all over the U.S. in New York, Illinois, Florida, and ultimately went to college at the University of Miami, or Miami University in Oxford, Ohio, where he got 2 bachelor's degrees, one a BS in zoology with a minor in neuroscience, and a BA in psychology. Okay, so preparing himself for a career potentially in animal behavior. He did some undergraduate research where he examined interactions between crickets, which was preparing him to become a deer biologist, I believe. Also, functional herbivores. He then became a zookeeper where he trained cheetahs to stick their forelimbs through the bars. At least that's how I envision it. To have their blood drawn. And so, again, animal behavior. The tail. Well, he taught a cheetah to stick part of itself out of a cage and get stuck with a needle. That's impressive. I can't even get my dog to sit. Okay, so then I got the pleasure to meet Marcelo when he became a technician working on a project that we've been working on for several years, the South Florida Deer Study, which many of you may be familiar with. Heather and Hunter are both graduate students on that project. But it's a large-scale project with the Fish and Wildlife Service, NPS, the state of Florida, and we're studying deer-panther interactions. And part of what we're doing there was developing monitoring techniques for white-tailed deer. So we were approached by the state of Florida towards the end of that project and said, hey, there's a military base that's really curious about how their federally mandated prescribed fire program to build RCW habitats impacting the broader wildlife community. And we'd like to test some of these new techniques we've been developing for counting deer noses. You think you could come to North Florida and do the same thing. And that's where this project began. And so during this project, he has been the point of contact and the lead for everything going on at Camp Lane. And in addition to the 3 chapters he's going to talk about today, he also conducted some side projects while here. So when we first started working with BDJIF to get funding for Garrett's project, Marcelo was sent to the field to start the pilot study one summer. Then he also received or mentored 2 undergraduate researchers, both of which received funding for their research, and so he's had a tremendous impact on undergrads through his TAing and through mentoring. Part of what he did as the point of contact for Camp Landing was to develop a relationship there where I can say I think we've achieved something that very few researchers have achieved, and that is working hand in glove with a fire team down there to pull off some really interesting fire research to better understand how fire is influencing wildlife communities. So literally we find bats and we catch a bat, find the bat in the morning, and we try to set the woods on fire around it. That's really hard because you have to write a burn plan. And so we're scrambling to find bats, and then they can pull together a burn permit. All of this happened because of relationships Marcelo built. And so we were able to get a DoD legacy grant out of that relationship that Marcelo built. And so he continues to work on that and is actually going to write up some of those additional chapters following or additional manuscripts following his defense here today. And so he went to the field with many other graduate students. He caught deer, he caught bobcats. He jumped in everywhere he could to get more experience. He also took up hunting while here in the lab and actually killed his first deer at Dr. Ford's place. So thank you, Dr. Ford. And not only that, but he bow killed a deer on public land. And that is not easy to do. I imagine very, very few of us have actually done that before. And so he has really achieved a lot there. And it's, again, probably because of his understanding of animal behavior. Okay, and finally, he plans to pursue a PhD following this defense. And it's been very coy with many of my collaborators, and it's been in a game of cat and mouse, basically dodging a lot of offers from really good universities. So hopefully he'll find what he's ultimately looking for. And with that, I give you Marcelo George.
Thank you. I wanted to make sure my introduction was just as long-winded as my thesis chapters, and he did a great job there. So again, thank you for that introduction, and I'm Marcelo George, and like I said, we'll be talking about linking wildlife communities to Pyrrhic landscapes. We wanted to understand how environmental factors such as disturbance events land cover, and soil influence the wildlife communities in a pyrrhic landscape to better inform the wildlife managers. So fire is a naturally occurring phenomenon that has occurred long before humans, and we can see the evidence of that in charcoal evidence of wildfires, as well as charcoal-rich soil horizons in the pre-Quaternary period. And humans' first use of fire was suggested to be around when they first became bipedal, and has been suggested to be a key factor in our development. As such, Native Americans here utilize fire to exploit the land and increase their productivity of hunting and gathering. But in the 1900s, we see that the Forest Service decided to make fire control a priority. Thus began this public and agency trend of fire suppression, which greatly altered the historical ecological course of many ecosystems. One such ecosystem is the longleaf pine ecosystem, which is the archetypal fire-mediated ecosystem with one of the shortest fire return intervals in North America. It's characterized by longleaf pine trees with high resin content and which provide fine fuel inputs, as well as bunch grasses which desiccate and elevate the fuel for well-ventilated fires. Needless to say, this ecosystem success is largely tied to the presence of fire. But due to the historical fire suppression, mesification began to occur, whereby pyrophytic or fire-loving species were replaced by more mesic species, creating a damper, cooler microclimate and causing a positive feedback loop. This, along with conversion of lands to agriculture, led to 97% of the ecosystem being lost. This in turn impacted many endemic species so that now 2/3 of all species in the southeast of flora and fauna that are threatened, endangered, or in decline are associated with this ecosystem. This is making it a high priority for conservation. And as you can see in the map here, the hatched area was its historical range, where the green blobs are denoting any significant patches that are still remaining, the size of the blob, dictating how large it is. So in an attempt to cut back this mesification feedback loop and maintain remnant stands, methods for restoration include prescribed fire and hardwood removal. And prescribed fire is commonly used to restore and maintain the historical disturbance regimes, alter vegetative structure, as well as reduce the fuel loads here in the southeastern United States, or there in the southeastern United States. So this led us to the broad question of how does the use of prescribed fire in restoration of the longleaf pine ecosystem impact the wildlife within these systems? Specifically, we wanted to evaluate the influence of fire along with other landscape characteristics on mammalian predator abundance for Chapter 1, avian species occupancy and species richness for Chapter 2, as well as white-tailed deer population vital rates in Chapter 3 or objective. I'll use those interchangeably. So all of our objectives were conducted at Camp Blanding, a military base and wildlife management area located in northern Florida in a humid subtropical climate, which resides at the confluence of two ecoregions and is characterized by mesic flatwoods, xeric sandhills, as well as bottomland hardwood forests. And Camp Blanding has a mean fire return interval of about 3 to 5 years, depending on the land cover type. And as a military base, of course, they conduct military exercises as well as live fire exercises. So I tried not to die. So diving into our first objective, we set out to evaluate the factors that influence the relative abundance of predator species that are common to the longleaf pine ecosystem. To understand the importance of fire in relationship to other factors, we also evaluated soil productivity and land cover on predator abundances. So not only has this ecosystem seen drastic changes, but the predators within these ecosystems has seen considerable reorganization over the past 200 years. Large carnivores, including cougars and red wolves, have been extirpated. That is, of course, if you believe in red wolves, right, Miss Dr. Ford? And while the Florida subspecies of black bear has seen significant increases in populations from an estimated 300 bears in the 1940s to around 4,000 in 2017. And furthermore, the expansion of coyotes into the southeast has caused concern for managers as fawn survival rates are especially low in longleaf pine forests, potentially due to fire-facilitated predation. Many managed and protected wildlife species can be negatively affected by predation, including white-tailed deer, bobwhite quail, wild turkeys, and gopher tortoises. But understanding how fire influences the spatial variation in predator abundance within these frequently burned systems is largely unknown and a need to understand for predation risk. So how does fire influence predator-prey interactions? It does so by rapidly modifying concealment cover and food resources. The green magnet hypothesis suggests that herbivores are attracted to recently burned areas and exploit improved foraging conditions. But the rapid removal of concealment cover caused by fire can have variable effects on predation risk depending on the prey's escape tactics as well as the predator's hunting mode. For example, white-tailed deer were attracted to recently burned areas in the greater Everglades system where the primary predator is the Florida panther, a stalking ambush predator that utilizes concealment cover when hunting. Conversely, in systems where coyotes, a cursorial predator that pursues prey in open areas, are the apex predator, white-tailed deer were avoiding recently burned areas. So not only does fire influence prey, but fire can also influence the distribution of predators. And this has been suggested to be a potential mechanism whereby predator space use can be altered to indirectly affect prey survival. Furthermore, nest predation has been shown to limit avian productivity and has contributed to the decline of the gopher tortoises. Many important nest predators consume soft mass during the nesting season, and soft mass production can be reduced by frequent fire. Thus, utilizing frequent fire could be a mechanism to decrease predator nest encounters through reduced carnivore use of a burned area. Conversely, fire occurring during the nesting season could reduce concealment cover around the nest, making them more exposed, or even directly destroying the nest. However, if predators are avoiding recently burned areas, then the probability of a predator encountering that nest may still decrease despite the reduced cover and them being more exposed. Which this may in turn increase the nest success for numerous endemic species who nest in longleaf pine. So our covariates were compiled into land cover, fire history, and soil productivity, which depicts a management gradient, with fire being the most manageable all the way down to soil productivity, which is largely unmanageable. And we created Euclidean distance rasters to the various pictured land cover types. We created a soil productivity raster by combining the USDA productivity data with spatially referenced soil taxonomic data from Web Soil Survey. And lastly, we created 4 fire covariates: time since fire, mean fire return interval, the distance to recently burned stands as depicted here in red, in which we defined a recent burn as having a maximum of 1 growing season since fire. And lastly, pyrodiversity, which is a relatively recently studied idea, but those familiar with patch diversity can see the similarities. So to characterize fire richness, we created a 500-meter buffer around each camera, and we simply counted the number of unique time since fire values within each buffer, as seen here with the 3 values there. So if we focus on the bottom left panel, we can see that this is a 3 and not a 4. This is because the white space, we only did this for the fire history that we had available to us. And so this is a fragmentation metric in many ways, but instead of using patch fragmentation, essentially using fire characteristics as a fragmentation. So we developed a study with 34 locations, and we set them with a minimum of 3 kilometers apart, where we had cameras. On the left map, we see the location of each of the cameras, the distribution, in the context of the 2 ecoregions, the Sea Island Flatwoods to the north, which is much more productive than the Ridges and Uplands region to the south in brown, as well as the impact area, which we decided not to put cameras because mortars explode in there. So On the right, we see our soil productivity map with the darker colors being more productive, and we can see here along the ecoregion boundary line in black that there's a drastic difference between the the northern ecoregion and the southern ecoregion. So, to monitor, we set up HCO Scout Guard cameras on roads and trails to increase detection and record the images of the wildlife that pass by. And the camera surveys were conducted in the summer from June to October in 2017 and May to September in 2018. Differences in survey length were due to Hurricane Irma delaying this recovery in 2017 and the start of the hunting season in 2018. We identified all species using Media Pro image management software, utilizing their morphology, and we set their independent detections at a 5-minute buffer. We created species-specific capture histories and counts for each site and occasion to estimate their abundances, and we divided our predators into fawn and nest predators, acknowledging the fact that the fawn predators may still depredate on nests and hatchling. These were the fawn predators we expected to see. And here are the potential nest predators we expected to see, including the striped and spotted skunks, as well as gray and red foxes. So for our analysis, we fit a hierarchical single season, single species, and mixture model in the unmarked package to estimate the effects of our covariates on abundance. We used all possible additive and linear combination of variables, resulting in 256 candidate models. And we used AIC to determine the top model, and significance was set as at an alpha of 0.05, where marginal significance was less than 0.1. We considered each site year combination to be a unique site, as seen here in this chart. Following Fuller et al. In 2006, among others. And we chose to do this because we were interested in focusing on the factors that were influencing abundance rather than looking at the turnover parameters such as colonization and extinction. And since we only had 2 years of data, temporal replication was limited for these kind of dynamic models. So due to the drought conditions in 2017, and the Hurricane Irma in 2017, and more moderate conditions in 2018, as well as our temporally dynamic fire covariates, we believe this to be a safe protocol despite the sites being replicated by year. But to account for any potential dependence between site years, we included the effective year on both the detection and abundance portion of our models. And since we're focusing on the factors influencing abundance rather than estimating true abundance for the base, all these estimates are really talking about the relative abundance. So lastly, we chose to look at abundance because a predation event is based on the probability of prey being detected and then subsequently captured. If we decrease the abundance of predators, then the probability of an individual prey being detected would likely be lowered. So we would be lowering this part here. Simply put, fewer predators in an area likely means there's lower chances of being eaten. So, of the potentially detected species, only these 6 species had sufficient data to be analyzed, and coyotes were the most detected of all predators. In the interest of time, I'm simply going to go over the significant variables within the top model. Bobcat relative abundance decreased with higher diversity and distance to hardwoods, meaning they had higher abundance with fewer unique fires and when closer to hardwoods. And abundance also increased with a mean fire return interval, meaning they were more abundant with longer time intervals between fires. Lastly, we observed marginal support for increased bobcat abundance near recently burned stands, but it was not significant. Coyote abundance decreased with higher diversity and distance to hardwood forests and had marginal support for higher abundance near recently burned stands, just like we saw for the coyote. And black bear abundance declined the further away they got from mixed pine hardwood forests. Raccoon abundance increased the further away they got from recently burned stands and pine stands, and it also marginally increased with proximity to deciduous forests. And the Virginia opossum abundance decreased with increasing soil productivity, but these guys are generalists, and so they might be more abundant in less productive sites, we hypothesize, due to competitive exclusion from the higher productivity sites. And lastly, the nine-banded armadillo increased with increasing biodiversity and time since fire. So interestingly, we found a distinct lack of detection of these mesocarnivores historically considered common throughout the entire southeast, making them functionally extinct at our site. We found this to be true not only for the 34 cameras used in this objective, but also for the subsequent 2 60-camera grids utilized in the third objective, of which we did not detect any red foxes, and we did not detect any spotted skunks, which further had a 31-camera baited camera grid that was explicitly utilized to detect spotted skunks. So this phenomenon has been talked about for a little while now, but as far as I know, has not been explicitly tested before. We would suspect that with the expansion of coyotes into the southeast and becoming the apex predator, they're then suppressing these mesopredators. And there's some precedent for that at the continental scale with wolves, coyotes, and red foxes. But I raise the lack of detection as another potentially understudied phenomenon that warrants more research, and that the use of fire in the system may be further adding to this top-down effect that we might be seeing. Sorry. Okay, this graph condenses our findings in an easily digestible graphic with the positive values denoting positive association and vice versa, and an asterisk denoting trending but not significant. We see that fire influenced all species except for the Florida black bear and the Virginia opossum. Land cover influenced all species except for the nine-banded armadillo and the Virginia opossum. And we see that soil productivity was only influencing the Virginia opossum. Focusing on the two top fawn predators, we see that bobcats and coyotes avoided areas with greater biodiversity, a fragmentation metric on the heterogeneity of fire conditions rather than patch type, to remind you. And they were also marginally attracted to recently burned stands. This may be due to the increased foraging opportunities in recently burned areas while avoiding the fragmented habitats created by diverse fire regimes. Past studies have shown that coyote avoidance of fragmentation based on habitat patches, but our study is novel in that we utilized fire attributes as our designation of fragmentation. Shifting to the top nest predators, we see that raccoons were avoiding recently burned stands, as was corroborated by other studies. And one reason this might be is because of the lack of soft mass, as we talked about before, is an important food item, and many food-producing plants do not produce soft mass until their third or fourth year following fire. So, thus, frequent fire can be included as a tool for potentially reducing raccoon abundance in pine uplands, which may then reduce the predation of ground nesting birds and herpetofauna. And lastly, we see that the three aforementioned predator abundances increase with the proximity to hardwoods, and as we talked about before, hardwood removal is a management action in the maintenance of longleaf pine ecosystems. But we did have some limitations to our analysis. We likely violated the assumption of independence between sites for more wide-ranging species such as coyotes and black bears. And the effects of these, although the violations of these biased the actual estimates, another study showed that the effects of the covariates and the management implications remain the same despite this type of violation. Okay. So, a better understanding of factors driving the predator populations and communities can facilitate management decision-making and provide scientific-based justification for our management actions. So our results suggested that the hardwood removal and mosaic burning of longleaf pine ecosystems would likely decrease fawn predator abundance, potentially decreasing fawn predation. Furthermore, hardwood removal, along with maintenance of pine stands and frequent burning, would likely decrease nest predator abundance and potentially decrease nest predations. Although the timing of burning is very important so as not to destroy the nests. And although we suggest the potential for decreasing predations, future studies should directly test this and see if our proposed ideas would be valid. And also further investigation is needed for the aforementioned lack of detection of mesocarnivores in the southeastern United States. So moving on to our second objective, we wanted to assess the effects of fire, land cover, soil productivity, as well as forest structure on avian occupancy and species richness. So here I want to further dive into the idea of biodiversity, which we touched on previously, but this time through the lens of the biodiversity begets biodiversity hypothesis, which suggests that the diversity of post-fire conditions, biodiversity, promotes biodiversity. And this is an old idea which has now recently received more attention. Biodiversity is commonly characterized through the heterogeneity of age, size, and intensity of fire. And the fundamental mechanism driving biodiversity as a function of biodiversity is similar to the concept of landscape heterogeneity, such as climate and soils promoting biodiversity, in that the more niche space an area contains, the greater number of species it's able to support. So many studies have evaluated biodiversity at the large scale, global, continental, regional, but fewer studies have looked at it at these smaller scales where we're talking about local and management-oriented scales. And our scale is at the smaller scale, which more than likely we hypothesize that it's an ideal scale to test the limits of this hypothesis. This is because the hypothesis may not be supported at smaller scales due to the species-area relationships. As the patch size decreases, the number of species occupying that patch must also decrease. So this relationship produces the theoretical upper limit to the hypothesis, such that as scale declines, the theoretical limit is approached, and due to the patch size decreasing. So understanding this upper limit is really beneficial for managers as they're operating at this small scale. Furthermore, studies evaluating this hypothesis have had variable results, contrasting from strong positive results to no or even negative responses, and which elucidates the need for more research on this topic, as well as a scale that will be applicable to all managers and wildlife conservationists. So species richness is a common characterization of biodiversity. It's a vital component to ecosystem function and can be assessed at multiple levels, whether you're talking about the community, the guild, or even spatial scales at regional and continental. But the factors influencing species richness may not be scaling up to higher levels. Thus, estimations should be conducted at multiple scales to gain a better understanding of the factors influencing the community dynamics. Furthermore, species richness alone is not enough to inform management decision given the social, economic, and conservation importance of individual species such as the wild turkeys and red cockaded woodpeckers. As such, incorporation of species-specific responses to fire will also allow for the better conservation of sensitive, endemic, and game species. So species and guild-specific responses to fire are variable in both direction and effect. This is because the fire-mediated changes augment habitat structure and food resources, which have variable responses on the species depending on their species or guild-specific natural history traits. What do I mean by that? For example, the occupancy probability of a seed specialist pine siskin declined with prescribed fire, while a bark insectivore black-backed woodpecker was responding positively, despite them both being canopy nesters. Furthermore, in southern pines, avian diversity, abundance, and species richness have been shown to be greater in sites that were frequently burned, despite guild and species-specific associations having more variable responses. So understanding the species, guild, and community-specific responses to the spatial variation of fire may improve the understanding of the avian community ecology and the efficiency of the restoration efforts to promote biodiversity. So to understand the relative importance of the fire, we again examined multiple other factors, including soil productivity and land cover, as well as habitat structure. So to record the detections of avian species, we implemented an acoustic survey with 34 sites that were no more than 200 meters away from our first objective, to give you guys an idea. Again, they were separated by 3 kilometers. And each of the survey sites, we mounted a programmable acoustic recorder to record avian chirps, calls, and vocalizations, or songs. Surveys were conducted at a time of year that coincided with the breeding and chick rearing season. And they were set to record for 3 5-minute intervals per day for 6 days. And the surveys occurred at sunrise, 1 hour after sunrise, and 2 hours after sunrise. We selected 53 target species, of which here is the shortened list. The that are common to the frequently burned forests in Florida, and grouped them by nesting behavior, including ground, cavity, tree, shrubs, as well as foraging behavior, and defined by their hunting strategy and diet, such as a ground omnivore, as you see in these columns here. We excluded the cedar waxwing and the sandhill crane, as well as the pine siskin, from our foraging guilds, as their foraging behavior could not be grouped or be incorporated to any other guild. And we chose to include nesting behavior as a grouping variable since we surveyed during the nesting season, and nesting is an important history stage in avian population dynamics, which can be largely influenced by fire. And we chose foraging behavior as a grouping variable since foraging has been shown to respond differently to restoration efforts, specifically prescribed burning and silviculture. So after researchers that completed 10 hours of song identification training, we interpreted the acoustic files and identified the species in each 5-minute session. So we employed a hierarchical community occupancy analysis and a Bayesian framework to estimate the effects of our covariates on species richness and occupancy. These models estimated the effects of the variables on occupancy of individual species, which were then utilized to estimate the effects of those variables on species richness. The advantage of using this over more traditional models is that this approach allows for both the species level effects as well as the aggregated effects of the variables on the community or guild level simultaneously. We used occupancy models due to their ability to account for imperfect detection, and we created species-specific capture histories just like we did in the first objective, but this time a 1 signified if they were detected and a 0 signified if they were not detected. So further, we utilized data augmentation, which allowed us to make inferences on species that we potentially failed to detect. And we added 5 all 0 detection histories to our data set for potentially undetected species. Again, we considered each site year combination to be a unique site, as we did in Objective 1, and for the exact same reasons. And we developed variables that represented our hypothesis regarding the influence of species occupancy and created a global, null, and all possible combination of models, variables resulting in 256 candidate models. And we fit all models to the entire data set, as well as the subsets of the nesting guilds and the foraging guilds independently. Again, because we interpreted the factors influencing occupancy, we were interested in the factors influencing occupancy rather than getting a true estimate of occupancy. We focused on the differences in relative site uses across site. And we included the year on both the detection and occupancy portion of each model. We then used deviance information criterion to determine the top model and assign significance when credible intervals did not overlap 0. So to evaluate the effects of our covariates on avian species richness and occupancy, we created covariates in the same way we did in Objective 1, and we utilized these 3 land cover types. We utilized the same soil productivity and fire covariates as well, presented here as a simple refresher. And again, of course, we included biodiversity as previously described, as we wanted to test the biodiversity begets biodiversity hypothesis. In addition to all those, we created a spatially explicit forest structure metric using 2014 land fire data set, which essentially just produces a percent canopy cover across the base, with the darker areas being a greater percentage of canopy cover. And we utilize that as it seems to be an importance for avian species. So we had sufficient data to model the occupancy of 48 of the 53 species, and as well as the 4 nesting guilds and 6 foraging guilds, along with the entire community. So the top model predicting species richness for the community level included biodiversity, pine forests, and distant deciduous forests, but only biodiversity was a significant variable, and the community level species richness increased with biodiversity, as we can see by the solid red line as well as the confidence interval red dashed lines. It's butting up right to 0, but not technically hitting 0. So And at the species level in the community model, we see that the northern parula also increased occupancy with increasing biodiversity. But note that most of the betas across all our species are running over into the positive side, and only two of which are actually on the negative side. Furthermore, let's see. The probability of occupancy increased for white-eyed virals and house wrens from 2017 to 2018. So jumping to the guilds, of our 4 nesting guilds and our 6 foraging guilds, only the cavity nesting guild was significantly influenced by our covariates. In the top, on the left side, we see that the cavity nesting guild species richness decreased with increasing time since fire, as shown again by the red, meaning that there were more species when fire was applied more frequently. And although not significant on the right, we see that there was also species richness was trending towards decreasing with increasing distance to open habitats. And at the species level across both graphs, we see that all species occupancy estimates were negatively associated with increasing time since fire and distance to open habitats. But only the brown-headed nuthatch occupancy significantly decreased with increasing time since fire, and the gray-crested flycatcher and red-bellied woodpecker, probability of occupancy significantly decreased with increasing distance to open habitats. So, at the community level, we identify this positive effect of biodiversity on species richness, potentially due to the diversity of conditions found in the area with greater biodiversity, likely providing greater ecological niche space. This supports and it further extends the biodiversity begets biodiversity hypothesis for avian species, and especially at the management scale, which is more applicable to management decisions, obviously. And previous studies have had equivocal results, but this may have been due to the variability in fire characteristics such as intensity, size, as well as the cause of the fire, whether it was a wildfire or a prescribed fire. Since we utilize the low-intensity prescribed burnings common to longleaf pine ecosystems, this allowed us to minimize some of that variability in fire characteristics relative to other studies that had mixed severity fires. And our study supports the finding that biodiversity begets biodiversity at these smaller scales. Our study also supports studies that found that factors influencing one level, like our guild, did not always scale up to the higher levels, the community. We did not see the same covariates influencing both levels. And our results highlight the importance of studying species at multiple levels and organizations simultaneously to get a better understanding of the effects of fire on the avian community dynamics and which natural history traits are at play. We offer evidence to support the linkage between biodiversity and biodiversity, as well as understanding the scale of your analysis. But the underlying mechanism behind the biodiversity begets biodiversity hypothesis still remains an open question and needs to be further investigated to benefit managers and conservationists who wish to promote avian biodiversity. So lastly, yes, 3 chapters, I'm sorry. Lastly, we investigated the influence of fire, soil productivity, and predator activity on fawn population vital rates. So recruitment is a fundamental process that heavily influences ungulate population growth, and understanding the factors driving recruitment are necessary for population management. So recruitment, as you can see here, is broadly defined as the introduction of new individuals into a population, either through immigration or birth and survival to a defined age. And although adult survival is commonly considered the driver of ungulate population growth, ungulate juvenile survival is lower and much more variable. Thus, understanding the factors influencing juvenile mortality is also important due to its variability to density-dependent factors and environmental stochasticity. So white-tailed deer recruitment in parts of the southeast have declined, and high neonate depredation is thought to be the important caustic factors in that decline, as seen here with Kilgo 2010's graph denoting the in-harvest fawn-to-doe ratio with the aforementioned increase in coyote populations in the southeast in particular. So predation is the greatest source of fawn mortality in North America, yet the variation in rates and sources of mortality across the landscape suggest that fawn survival may be influenced by landscape characteristics as well. And deer fawn survival rates, like we mentioned before, are particularly low in longleaf pine forests, and we potentially think that might be due to the fire-facilitated predation, because fire, again, alters concealment cover and consumes vegetation in recently burned areas, but it also may be beneficial as it improves the quality of forage, which is often associated with increased survival and population growth. So understanding the influence of fire and landscape characteristics during longleaf pine restoration is important, as it may impact the population rates of an important primary functional herbivore in the ecosystem that also generates substantial revenue for conservation efforts. As such, we utilized a novel, non-invasive spatial capture technique to examine fawn births and recruitment across Camp Blanding. We developed a study with 2 remote sensing camera traps array consisting of 60 cameras to estimate the effects of our covariates on fawn population vital rates. The arrays occurred at the interface of the 2 ecoregions, which gave us the opportunity to examine the effects of environmental factors at broad scales such as weather and climate and human disturbance, as well as fine scale ownership and management, but which were drastically different in their soil productivity and botanical communities. And cameras were placed on roads and trails and habitat edges across a wide range of land cover and fire history conditions. Surveys were conducted during the summer, as this was the fawning season, and we separated cameras by approximately 500 meters to detect individual fawns at multiple cameras. So we interpreted the images using Media Pro software again, and we uniquely identified fawns by their spot patterns as seen in the sequential images of this individual fawn, with the blue and red circles highlighting distinct areas. You can see a little couple patterns that you can follow that fawn through its lifetime. So fawns that had left or right flank photos were combined when fawns were able to be joined by full visibility of one flank while partial visibility of the other within the same photo, or the photos were 5 seconds apart and there was no other fawn detected within that fawn bout. But partial identity occurred when spot patterns from the left and right flanks could not be combined into an individual, at which point they were discarded for analysis, because the inclusion of these partially identified fawns could result in a biased vital estimate, as the model would be considering them 2 fawns when in reality it could just be 1. Detections of any individual occurring within 5 minutes of a previous detection at that same camera were discarded to maximize the independence between our samples. And we estimated individual fawn birth dates with a maximum and minimum birth date range using morphology at the first detection of that fawn by an expert who has extensive experience in deer husbandry and bottle rearing captive fawns. Furthermore, we identified fawn predators species, which consisted of American black bears, bobcats, and coyotes, and then we created individual detection histories and applied our spatially explicit covariates as represented here by these 2 graphs with coyote activity and soil productivity, and the white denoting the detections for this individual. So for our covariates, we utilized time since fire and soil productivity as we've shown before in the previous objectives, but additionally we created a predator activity surface from capture histories describing the predator detections in both years and grids for coyotes, as well as the entire fawn predator community, the coyote, bobcat, and black bear all being combined. So while bobcats and black bears are known fawn predators, coyote activity was included independently because coyotes are typically the most important fawn predator in longleaf pine systems, as well as they were the most frequently detected predator on our camera sets, and the only predator that was detected depredating fawns, with an N of 14 photos of depredated fawns, which were split evenly between the north and the south, 7 and 7. So didn't really tell us much. But And with that, we fit a Poisson generalized linear model, including camera-specific counts of detections as our response variable, and the distance to the reclassified land cover types and soil productivity as explanatory variables. We also included a log trap days to offset in our GLM, allowing for the prediction of camera-specific predator detections rates as an indices of this predator activity. And we estimated each year array combination independently to accurately represent the risk within that year and array. As such, the high activity areas in red are relative to only that grid, and they should not be compared across grids. There's not necessarily more coyotes in the south than the north, and these were all scaled from 0 to 1. We used AIC to compare the top model and then use that top model to predict our predator surface, which would then be used as a covariate in the fawn model, if that makes sense. So we estimated fawn births, recruitment, and the effects of covariates on the density of fawn birth site locations and the number of recruits based on the modeling framework of Chandler et al. In 2018, which extends recent spatial capture recapture advancements that allow for the estimation of survival and recruitment while accounting for individual variation in detection probabilities. So this is a hierarchical model that utilizes the spatial temporal point process model to estimate the number, times, and locations of births while simultaneously using a failure to time approach to model survival to a given age, i.e. our recruitment age that we talked about before. And we incorporated the estimated birth date ranges into our survival model to account for the fact that fawns are rarely detected in the first few weeks of their life, so that this will allow us to estimate their age better and improve our parameter estimates. So while Chandler defined the recruitment age at 180 days since birth, we used 70 days since birth as our threshold for recruitment. So when Chandler et al. Was studying a system where the panther is a efficient predator of deer of all ages, but in the absence of such a predator, several other studies in the southeast have reported negligible depredations past 50 days of age for fawns. So if the fawn was detected past our 70 days of the recruitment age, then we would consider them recruited into the adult population. And survival was modeled with a fawn lifetime as a random variable. Spatial variation in the density of birth locations is modeled with our spatially referenced covariates. Bayesian methods were used for the statistical inference, and the analysis was performed with a custom Gibbs sampler, again created by Dr. Chandler et al. In 2018. And we fit 8 a priori models, including a null model, to each site year independently. So all our models represent all possible combinations of time since fire, soil productivity, coyote activity, and the cumulative predator activity as predictors of fawn birth site density, or gamma, as seen here in the table. And we use total model deviance to compare model weights and identify the top model. And parameters were again considered significant when their credible intervals did not overlap 0. Additionally, I incorporated into this model a mechanism to randomly sample an area with hard boundaries where fawns are not present, as in the case with the 2 lakes in the southern grid within our southern array. As we see here, the white space denotes where the lakes would be. I didn't have to show you this, but I'm very proud of that fact, so I decided. So posterior mean birth dates were similar across years, or across arrays, but varied across years. But they're actually doing really well with our expert estimated average across both years, and a literature-derived reporting of peak birth. So likely peak birth on Camp Blanding is occurring between late May and early June. So the number of births were similar across years, but higher in the north array compared to the south. But were not statistically different in 2017 due to these massive credible intervals. Despite this, the number of recruits was greater in the north array compared to the south for both years. So our results indicate that the north array hosted a higher recruitment for both years and more births in 2017. The graph below depicts the birth site densities with births per kilometer squared across both grids and years. Although the top models included variables We found no significant effects of our spatial covariates on any grid year combination. But let me remind you that we were only analyzing each year array separately. So this doesn't take into account the variation we might have seen between arrays, but rather only within an array. So all in all, we examined fawn birth and recruitment at the boundary of 2 Florida ecoregions and provided spatially explicit estimates of density and birth sites of recruits. We did not find effects of our spatial covariates. The variation may not have been large enough to influence the differences within the arrays, or they may not be influencing birth site density and recruitment at all. However, the variation in these and other characteristics may be what's driving the differences we saw in births and recruits across the 2 arrays. Right? In the future, we plan to rerun this analysis and compare the effects of the covariates across both arrays by combining them both within this framework and then utilizing one covariate across both of them to look at the differences between sites. So the attributes of the north not only produced more fawns, births, but meaning that their attributes likely better met dam nutritional demands, but it also sustained a greater number of fawns that reached recruitment age, also meaning that they likely were better protected, the fawns after they were born, either through, protecting them from predation and starvation. So this study recorded vastly different recruitment rates across 2 sites that are very close in proximity, suggesting that the population vital rates can vary at small spatial scales, which is supported by some previous studies. One major limitation to our study was our low sample size, and this has likely come from 2 different factors. The first being the size of the area that you sample has to be large enough so that there's an adequate number of deers detected there to give you enough statistical power. This is going to be super hard in low density areas, as we saw for the south grid, especially in 2017, where we had very large confidence intervals and very small sample size of detections. Second, the low sample size can come from the inability to combine left and right flank fawns, right? Because it's only based on how they were detected if they were close enough and stood around long enough. But you can get around this by either pairing cameras at each site, so you have 2 and you detect both flanks simultaneously, or you can utilize the spatial partial identity model, the SPIM model that Ben Augustine created here at Virginia Tech, which probabilistically resolves the uncertainty of partial identity of individuals using their location and time of capture. So what do these differences mean between the north and the south? Well, they actually illuminate a unique problem where you need to set your harvest goals to your restraints within your habitat. So even though this is an area that's managed under one management agency and for all the same objectives, you might actually need to set your harvest goals in the north different from your south, right? Because if you have 12 deer in the north and 6 in the south, and you say you can take 3 deer a year, the effect and the magnitude of that harvest is going to be much larger in the south, where you have fewer deer than you would have in the north. So this actually just reinstates the idea that we need to make harvest rates that are going to match doe or fawn recruitment, so that the effect of that harvest is uniform across the entire area. So in conclusion, we saw that biodiversity negatively influenced coyote and bobcat abundance while positively influencing the avian community. Recent burns negatively impacted raccoon abundance while cavity nesting guild species richness increased with decreasing time since fire. And we found differences in fawn population vital rates across the north and the south, likely due to the difference between the 2 ecoregions. And lastly, we found a distinct lack of mesocarnivores that were historically common throughout the southeastern United States across all the cameras that we ran. So our work outlined the importance of understanding the effects of prescribed fires on wildlife communities. Based on the results, we can see that utilizing fire may have the unintended benefits of potentially deterring predators such as coyotes and bobcats, as well as raccoons, while also promoting avian species richness at the community and cavity nesting level. Furthermore, the varied fall and survival rates across Camp Landing outlined the need to set different harvest quotas across the base so that the effective harvest is uniform and sustainable. With that, I'd like to thank Camp Landing Joint Training Center, the Jones Center at Itchaway, Virginia Tech, as well as the Florida Fish and Wildlife Conservation Commission for their funding, logistics, and equipment support. And I'd also like to thank my committee, along with Dr. Cherry, for giving me the opportunity to do this and for supporting me through it. I'd like to thank Alan Hallman, who, without his help, this project could not be done. He's a crazy man that does crazy work. And Matt Corby and Mark Bitchell for their vigilance in not burning up my equipment during their prescribed fires. The Garrison family for allowing me to stay at their house, having me over for dinner, and especially for allowing me to play with their dog Teddy and their chickens. All my departmental peers, especially when I was in a lab all by myself, you guys adopted me into yours, which was really nice. You helped me brainstorm ideas, and we had great conversations. And then my lab mates for finally joining me along and sharing their knowledge with me and becoming, great friends in the time being. All the volunteers and technicians who have helped me through the mountain of data that I've collected, including Nina and Tavante, the 2 undergraduate students who took special interest in the work and allowed me to mentor them through their own independent projects along with Dr. Cherry. And I'd like to especially thank our departmental staff, especially Michael and Susan, who are always greeting us with a smile and always reminding us everything's going to be okay. And lastly, my family, of course, my mother and my father and my little sister, who's actually older than me, as well as Lisa, my girlfriend, who supports me through all this, even when I made plans to quit, buy a sailboat, and go sailing across the world, despite having 0 sailing experience. We could still do it. But at this point, I'd like to answer any questions you guys might have. My Vanna White will come around with a microphone, so I don't have to repeat it.
Yeah, if you can't project, I have a...
George.
I can project. I assume that different parts of the base experience different levels of human activity, and how do you think that impacts the other mammals?
Yeah, so the other thing I really wanted to look at, which I didn't get a chance to, was using their firing ranges as a covariate of like distance to mortar impacts and 50 cal bullets and see how that affects wildlife communities. Unfortunately, the military are real tight with that kind of information and like how many bullets they shoot all the time. So I didn't get a chance to look at that. But that being said, there's gun ranges on both the north and the south post. Granted, the explosives are more towards the south, but there's vehicle maneuvering and people walking through the woods across both sides. So it's hard to tell like if one would be greatly more aside from the impact area, which we ignored for that exact reason and because I didn't want to die. Heather.
Great job.
Thank you.
My question has to do with the bobcat and coyote having similar relative abundance at recently burned sites in prior diversity. So if that's interesting despite their different hunting strategies,
Right.
Why do you think that is, and did they vary temporally?
Right. So I think that the big reason that is just it's a smorgasbord of small mammals after a recent burn. They don't have any concealment cover. And so I think it just facilitates hunting regardless of their hunting strategy. I know bobcats are usually going to be more ambush, so you would think that. But I think because they're so at risk within that recent burn that the bobcat literally can kind of abandon this whole ambush thing and just literally go out there is my hypothesis, but I really don't know. And I didn't look at temporal variation that much. I know Tavante did, but I have to go back and think about what the results were. But I imagine that coyotes they're going to be slight variation because there's going to be that competition between the two.
So it's interesting. I like how you, in your, I guess it was your 3rd chapter, you looked at recruitment and then talking about how you could actually try to match harvest to recruitment.
Yeah.
In essence, is that feasible though? Because that was a relatively small base, and can the management agency, can they design seasons and harvest rates at that fine of a scale to accommodate that?
I think the base can really do that through closing of areas, because it's very common on the base to close certain areas at certain times for military training, or they were offering to close some of the areas while we were doing bat burning. So potentially you could kind of do that by taking away some days in the south and making more harvest days up in the north, but
That'd be base specific rather than.
it'd be at the base level, right? Exactly. Sorry, not at the
Strong relationship to recruitment and soil productivity.
likely we'd think so, although we haven't explicitly tested it. We would expect to be soil productivity and the intrinsic values of that, such as foraging availability, concealment cover, that goes along with that soil productivity. But potentially at this base level, you could, because it's a military base, there's a lot more restrictions that you can just throw on there. So like after 9/11, they closed down the base for like 4 years and there was no hunting. So they have a little bit more leeway, but I don't know, if FWC would be able to functionally do this right now. Yeah, sorry, I'll go back there and then forward.
What are the rates of adult movement, sort of between your north and south?
So we haven't looked at that yet. We're trying to suggest that we give a little collar study out there, but we haven't looked at that yet. I'd actually imagine there's a lot of barriers of movement between the north and the south.
We get your mortars.
Yes, the mortars among all things, and then there's a lot of traffic on the roads in between there that are likely going to deter them. I wouldn't say there's that much movement between the north and the south, because that impact area covers a lot. And there was a study that showed that like 50% of adult mortalities on this other military base were due to mortars and bullets, and so it could be potentially a really hard boundary that stops them from going from north and south. But I'm not quite sure. Yeah.
Yeah, that's what was going to be my question, because even though they may recruit to the south or the north, who's to say they might not emigrate?
Immigrate up,
So
right.
setting management or tags separately could be influenced by immigration and immigration.
Absolutely. Yeah, which is something we didn't really take a look at.
You kind of briefly touched on it, but do you think that there's similarity in terms of fire intensity and when fires are due to what historical patterns would have been, and could that affect things?
So yeah, seasonality of fire has been shown to be influential in a lot of different systems for a couple different species. I think the good thing about Camp Blanding is they burn both in the winter and in the summer. They burn all the time, anytime they can. They go and find a little patch. So we had roughly even amounts of that. So I didn't really look at the seasonality of it, but it does certainly play a role in what forbs and grasses are going to grow. And then potentially what species are going to come in and eat that as well. But unfortunately, I didn't get a chance to look at that. I had too many chapters. Neat.
So I'm curious about the relationship between biodiversity and soil productivity. So as you mentioned before, the north and south have very different ecoregions. So did you find any interesting relationships between biodiversity and soil diversity? Because I imagine in the south you're not going to grow anything even if you do burn.
Absolutely. Well, I think it'll grow, but I think there's a delay response there where if you burn in the north one patch and there's a patch that's unburned, you're going to see this clear delineation, a very hard line and edge there. But over time, you're going to see it grow back, and it'll be like, not that nothing was ever there, but it'll eventually grow back much quicker, and the concealment cover will be there. Where I'd hypothesize that in the south, that burn is going to take much longer for that concealment cover to return, so it's much more greater impact on prey species likely when it's burned in low soil productivity. There's no concealment cover. That's not me, is it? It's not me, as long as it's not me. Carry on.
So I was interested in the at least 2-week difference between peak fawning date in your 2 years. And I know in the bird literature, nest predation rates go way up when the main mammal predators are lactating. So when weasels or foxes get young that they're trying to feed, the energy demands of the female, fawn drop date versus when coyotes drop their pups, and whether those are likely to be correlated or not, and whether that could influence, like, could cause end variation in predation pressure.
Yeah, potentially. I think the greater thing is more nutritional status, and that like if you have poor nutritional status, it take longer to actually drop your babies. But which that's why I think there's a little bit of a difference between the 2 years, was with the drought in 2017 and then Hurricane Irma. This likely created their nutritional status for the next year to be much worse. So then you see a kind of a delayed in the birthing process. But yeah, I haven't looked at the coyotes and how coyote dropping pups would be influencing the predators as well. But it's an interesting idea, for sure.
So do you have any idea what the rate of twinning is?
Here in our system, no. I'll say very simply, I don't. But I could say, I would guess that it's actually very high, fairly high compared to South Florida.
Can you distinguish twins on your...
Yes, we can definitely distinguish twins. I saw, a couple of them there, and especially when they come to the same, in the same image, it's very easy to distinguish the two. They don't actually have the same patterns, but I suspect they actually have very similar patterns. Like you can tell someone's related, right? By, you have these similar features. I think there is that in fawns as well. I've not proved it whatsoever. Don't know how to yet, but after looking at tons and tons of images, I do think that there is some sort of relationship there, that you could see that their patterns are more closely related as their lineages are. But I don't know.
All right, well, we're a little over. Such a great conversation. Let's give him one last round of applause. And y'all can catch up with them outside if you have more burning questions, and the committee and I will catch up with them here.
Interrogate. And I'll send the Zoom out, link to the Zoom for everyone. Thank you. Oh, yes. I was going to say something about that. I was like, if you prescribe to the Berman Anderson Church, this is not what you want to see. But yes, no, I definitely.
So the bird work, that was breeding season?
Yeah, early, and then chick rearing and like just barely. It wasn't many. Yeah.
They were a far northern species.
Mm-hmm.
Don't count your
Maybe.
What they had. Yeah, you guys are good.
That was really good.
There's a lot.
Pretty good, like half of a PhD presentation. Pretty much, yeah.
I'm sitting here going, I'm not gonna.
I mean, I might not be able to, but I mean, honestly,
You set the bar high for everyone.
I had so
Yeah.
much happening. Having to
You did
move
good.
over to
I'm very proud of you.
I mean,
Glad I made it. Oh yeah. Well, I just wanted to look better than
I
Hunter
mean,
too.
is that just,
I mean,
is
you
that
don't have to try that hard.
Huh?
we're not for,
But it's, I mean, it's your day.
Oh.
maybe we.
I'll take it. I'll take it.
I have
Is this
an
from?
appointment on
That's
Wednesday.
part of that's from the TWS stuff. It's so good.
What?
You did really good.
Yeah, I mean.
Got worse as we know.
Tuesday and
So you guys tried to watch this.
more cardio is better for everyone, right?
With the what?
I gave them the
You know what I mean?
Oh, okay. Well, it's recorded.
Well, I feel like
yeah,
you probably
we'll
have
put it
more
on.
people that'll show up than me. So.
You did great.
Thank you.
Let me know when you come on.
Yeah.
I'm at 45.
Yeah. No, I kept saying small.
Right. I just.
Thank you.
Get ready for tomorrow.
Today, you mean?
Today?
1:47. Just right after this.
Are we doing this today?
No, I'm saying it's
Oh, I meant.
Leonard, can you meet up with our IT guy and ask if it's done recording to stop recording?
Yeah, I think what you do.
Well, he's got his office here. I'll let you solve that, please.
Yeah. You're good, man. Congrats.